Hi friends, today our topic is necessary of starter. Necessity of starter. The current drawn by a motor armature is given by the relation Ia is equal to V minus Eb Ra, whereas V stands for supply voltage, Eb stands for back EMF, Ra stands for armature resistance, and Ia stands for armature current. When the motor is at rest, it means at starting time there is yet obviously not be back EMF developed in the armature because rotor is in static position. Means during starting, when rotor is static position, no back EMF in the motor. If how full speed voltage is applied across the stationary armature, means starting if you give a high voltage full supply voltage to the armature, then it will damage the rotor, means it will draw a very large current because of armature resistance is very small, means armature resistance is very small. So that during starting period motor draw a large amount of current. Now I will explain it by example. Consider V is equal to 440 volt, P means power is equal to 3.73 kilowatt or 5 HP. Ra means armature resistance 0.25 ohm. Full load current 50 ampere that flow through the armature of the rotor, means full load current 50 ampere. Now if this motor is started from the line directly voltage, means direct line voltage, it will draw a starting current of, means starting current draw by this motor is equal to 440 volt divided by 0.25 resistance, means current flow the armature Ia is equal to 1760 ampere, of which 760 divided by 50, this 50 is a full load current, both are in ampere, so the ratio of these two current is 35.2 times its full load current, means 1760 is 35.2 times bigger than 50 ampere. This excessive current will blow out the fuse, and prior to that it will damage the commutator and brushes. To avoid this happening, a resistance is introduced in series with the armature only for during starting period, which limit the starting current to a safe value, means this is the armature of the motor and the resistance is connected, variable resistance is connected to the series of the armature. The starting resistance is gradually cut out as the motor gain speed and develop the back EMF which regulate its speed. Very small motor may however be started from rest by connecting them directly to the supply line, like small AC motor and small DC motor, small AC or DC motor. In figure, resistance R is used for starting motor is shown. It will be seen that the starting resistance R is in series with the armature and not with the motor as whole. Means this resistance is only series with the armature, not with all the motor. The field winding is connected directly across the line. Field winding connected directly across the line voltage. The field winding is connected directly across the line. Hence, shunt field current is independent of the line. Hence, the shunt field current is independent of the resistance. Mean this current is independent of the resistance. If R is connected to the shunt field current, mean if this R is connected here, if R is connected to the shunt field circuit, that due to resistance R, ISH shunt current will be small at the start. Means shunt current is small during starting period. ISH is small. Hence starting torque TST will also small, because TA is directly proportional to phi into Ia, and phi is dependent on the ISH current, shunt current. It means ISH decrease, then 5 decrease, then torque of armature also decrease.